And finally figured out how to open these pictures in Paint, and now I can do anything I need to them. I can zoom, I can rotate. So there are 4 extremely important equations you need to remember when you're dealing with polar. One is x equals r cosine of theta. The other is y equals r sine of theta. R squared equals x squared plus y squared. And the tangent of theta equals y over x. Okay? Now, in a lot of these, you only need a couple of them. And this first one, I only need 2. In other words, what I want to do is convert that sine theta and that cosine theta in terms of x and y and r.
Okay.
So, if we do that, we get y equals what? 2 over... What's sine of theta going to be?
Sine of theta would be y.
Solve this equation over here for sine of theta.
Okay.
Y over r.
Yeah, y over r.
Okay. So I've got 2 times y over r minus what? 3 times what?
3 times x over r.
Yeah. In other words, these are actually pretty easy. Is all you have to, it's just substitution and algebra. Okay. Now, I can see that that denominator has a common denominator. So I can write it as 2 over what?
2 over...
You're subtracting fractions with a common denominator. Just operate on the numerator.
So it would be negative y minus x.
No. 2 times y.
So 2y.
Minus 3x.
Minus 3x.
Over r.
Okay.
In other words, just doing this part of it. I have 2 fractions with a common denominator. It's going to be 2y minus 3x all over r.
Okay.
Okay. Now, how do we divide by fractions?
What do you mean?
We flip and multiply.
Yeah.
I want to simplify that thing on the right. How does it simplify?
Okay, yeah. So we flip and multiply.
So 2r over 2y minus 3x, right?
Yeah.
Now notice the r's cancel. That r cancels with that r, but not totally. It leaves 1 behind. In other words, it doesn't make it disappear. So now I got to solve this equation. 1 equals 2 over 2y minus 3x. Well, that tells me 2y minus 3x is equal to 2.
Right.
Answer C. And that's the way almost all of these go. They're not really anything but difficult algebra.
Right.
Because that's all I did. There was no calculus in this. Okay. The next problem does have some calculus. Let me get some writing room here. Now, probably the most important thing you need to know about parametric equations is the following. dy dx is equal to dy dt divided by dx dt.
Okay.
And if you treat differentials like fractions, which I've been told for 40 years not to do, and yet they always seem to be treatable like fractions. In other words, all I did was divide top and bottom by dt. Forget that.
Mm-hmm.
Okay? But that is a true statement when you're trying to find. Now, we don't know the x and y equation here. So we can actually do this two ways. We could eliminate the parameter, turning it into an xy, and then we just take the first and second derivative of y.
Right.
But turning it into a parameter, not so easy. You got plus and minus on one side. When you take the square root of t, besides that, they don't want you to do it that way anyway. They want you to do it this way. Okay.
Okay.
Now, the second derivative is the derivative of the first derivative with respect to x. You with me?
Yeah.
Well, that means it's the derivative of this over here on the upper right, dy dt. You got to watch your fraction bars here. They tend to do it slanted so they don't get all mixed up. Okay, so this is going to be our answer. Now, what do we need? We need dy dt and dx dt. So let's go up to here where I've circled the function. And that's pretty easy. dx dt is what?
2t.
dy dt.
3t squared.
Now we just got to plug everything in. I'm going to work over here in that box. So, first thing we need is dy dt. So, first of all, dy dx. And now let's just write it like this. d of dy dx that way. Okay, I know our answer is right there. I just got to plug in everything. So, it's the derivative of 3t squared divided by 2t with respect to dx. With me?
Yep.
Okay, now I'm going to take and simplify that. So now I'm going to take the derivative of 3/2 t dx. Well,
Would that just be 3/2?
Well, first of all, d that dx means d of this dt divided by dx dt. Okay, and the derivative of that is 3/2 And we're dividing it by 2t.
So then it'd be 3 over 4t. I'm confused on why we're dividing it by that.
Yeah. I think I made a mistake here when I did it earlier. Hold on a second. Let me look at this. So dy dx is 3/2 t. And then we're going to take the derivative of 3/2 t, but with respect to x.
Right.
T is equal to plus or minus x minus 1, square root of x minus 1. Question is, how do we do that? Well, if we are, how do we do that? See, the way I did it, what do I get? I get 3/4, the number 3/4, and that's not an answer, so I must have done it wrong. Let me think about this for a second. This is not that hard. You look in the book. They came up. Oh, okay. Now we're. No. Got a problem very similar in my book where you have x and y as functions of t.
Right.
Find the slope. Well, that's what we're looking for. No, we're looking for the second derivative. They wanted to solve for concavity also. In example in my book, they're solving for slope and concavity. Well, slope is dy dx.
Right.
And concavity is where the second derivative, dy dx, is greater than 0, or whatever it is. If it's greater than 0, it's concave up. If it's less than 0, it's concave down. Let me just look quickly here as to... Okay, so you can define dy dx in terms of t, which we did. It's 3t, 3/2 t.
Okay.
Now you can find the second derivative. Okay, hold on a second here. Let me see if I can... God, I hate to erase all this, but I'm going to. Because this will tell us. So in my problem in the book here, I got dy dx as being equal to t to the 3/2. I can't write in that area either. Amazing. I didn't realize in Paint I could write without turning on my thing.
That's helpful.
Well, it is, I guess. Although it doesn't give me the option. There's probably here's the erase button right there. No, not that helpful. Hold on a second here. Let me do something else. I want you to understand this, and I want to make sure I'm giving it to you right.
Right.
Okay, so in this other problem, not virtually identical, but very, very similar, we figure out that dy dx is t to the 3/2. And we also know dx dt, let me put that over here, dx dt equals 1/2 t to the minus 1/2, and dy dt equals, oh Lord, dy dt equals 1/2 t.
Okay.
Okay, so very similar. In our problem, we solve for dx dt, we solve for dy dt, and that gives me dy dx. Notice that if I try to find dy dx, it's dy dt divided by dx dt, which gives us t to the 3/2.
Right.
All right, now to find the second derivative. This is where things get a little bit complicated, I think. I don't think they really need to be. So it's the derivative of dy dx with respect to dx dt. That's not intuitively obvious, is it?
No.
In other words, I would say it's in respect to dx, but it's in respect to dx dt, and I think that's where I'm getting confused here.
Wait, why is it dy dx on top and not dy dt?
Well, because dy dx is dy dt divided by dx dt.
Okay.
So that, besides that, that's dy dx, and they've asked for the second derivative of that. So I really am taking the derivative of dy dx. Now the question is why is the bottom dx dt instead of just dx? But that's where a misunderstanding comes in. And as long as I take this as gospel, and I believe it because it's in my book, now I'm going to take the derivative. I didn't write this correctly. There we go. Now it makes more sense. See what I just did?
Yeah.
In other words, second derivative of dy dx is the first derivative of dy dx over dt divided by dx dt. Now that dt in the bottom makes perfect sense because all I did was divided top and bottom by dt.
Right.
So now if we plug in, we know what that is. So we're taking the derivative of t to the 3/2 dt. That's the numerator. The denominator we've already solved. Okay. Now, let's see, let me go down here to continue this. The derivative of the numerator is 3/2 t to the 1/2, right?
Right.
And the bottom is 1/2 t to the minus 1/2. And that comes out to be 3t. The 2's cancel, bring the bottom t to the top, and you end up with a full t. So the slope is 3t. Okay? Now, if you give me a point on that curve, then I will find out, given an x, I can find out what t is.
Right.
So give me an x and I can figure out a number on that slope. If I want to know the slope when x is equal to 2.
Okay.
I got x, this is the original equation. If x equals 2, then t equals 4. So I just plug in 4, and so t is 4, so this second derivative is 12. 12 is positive, therefore it's concave up.
Okay.
You with me? Or did I lose you?
No, I get it.
Okay. Now let's see if we can translate this to your problem. This thinking here. Okay. Should be a piece of cake. Hold on. Let's see where I went wrong on mine. Okay, let's see. So we start here at the top. Let's first figure out, we know we're going to need dy dt. That's 3t squared. We know we're going to need dx dt. You always do these problems. That's 2t. So the first derivative is dy dt divided by dx dt. So
yes.
dy dx is going to be 3/2 t. Second derivative. That, whoops, it's always written a little funny. Put the 2 to the right of the x when you do it. I don't quite know why they do it that way.
Me neither.
That's the way they do it, though. That's what that means.
Okay.
So that's equal to d of 3/2 t dt, all divided by dx dt. That's right there. Okay, well, what does that equal to? The derivative of 3/2 t is 3/2 in the numerator.
Right.
Dx dt is 2t. Flip and multiply, and you get 3/4t. A.
Wait. Yeah.
That's why t ends up in the denominator. If I put a 1 under that, flip and multiply, I get 3/4t.
Right.
Okay, let's go on. Sorry to take so long there. That's the confusing part is that dx dt in the denominator.
Yeah.
Okay, converting this rectilinear to polar form is actually, this is one of the easier problems. If we start with, whoops, did it again. I want to use this, not that. I don't like using this when I'm in paint. Oh, that's funny. Okay, so I got y squared equal 3x.
So we're gonna use the equations r squared equals x squared plus y squared.
Yes. So no, we're not going to use that. We're going to use this equation. X, these are the more common equations you use. These two.
Okay.
I think that's all we need on this one. So I'm going to substitute for y squared, r squared cosine squared. That's the left side.
Right.
And I'm going to substitute for x like that. Now I'm home. I can divide both sides by, you know what? You can't divide both sides by cosine of theta. Why not? I can't divide both sides by cosine of theta.
Because
I can't divide both sides by r.
they're different terms?
Because they can there are times where cosine of theta is 0.
Right.
You can't divide by 0. And if you find yourself dividing both sides of an equation by a variable that can sometimes be 0, you lose the 0 solution that you would have found.
Right.
So I'm going to take everything on the right and move it to the left. So I have r squared cosine squared of theta minus 3r cosine of theta equals 0. Now I can factor.
Factor out an r. Or
Yeah. So r times, well, you can factor out an r and a cosine theta. Right?
right.
And leaves behind r cosine theta minus 3 equals 0.
Right.
Now, which means either that's 0 or that's 0.
So
I got that. Oh, I know what happened on this. What did I do? I did something different. Oh, you know what I did? I did do what I told you not to do. Let's see what happens if we do that. Yeah, let me go back here. For some reason, this isn't helping me because we're not solving for r. We need to solve for r. I guess I could divide everything. No, then I haven't solved for r. Yeah. Here's what I did. Y squared is r squared over sine squared. This is 3r cosine of theta. And then what did I do? I did divide both sides by r. Now maybe I can do that because I don't think r can be 0. Okay?
right.
Yeah, now it's actually a piece of cake because now you get r equals 3 cosine of theta sine squared of theta. And that is the answer. I mean, I didn't do anything wrong, I don't think. I think I can divide both sides by r because r is never 0. Or if r is 0, then it's a point. It's not
Right.
really an equation, it's a point.
Right.
And notice that this answer is not on there.
So it should be E.
And I checked these two just in case there was a trig identity that made those equal to cosine sine squared, and they don't. The cosine sine squared ends up in the denominator on that one. And I don't remember what happened on that one, but let's see, that would be 3 over sine times, let's see, that's cosine over sine. So that'd be cosine over sine squared.
Right.
So neither of these fit. So it's got to be none of these. Do you have the answer keys on these?
I do not, but they will probably be posted soon, so that I'll be able to check.
All right, we can check before tomorrow's appointment, I suppose. You're going to have another paper for me tomorrow?
I will probably, yeah, I'll send.
Will it be on the same 2 subjects?
Yes.
Good. I'll just read, because these can get kind of hard. What we're having today is really more algebra than it is calculus. Number 2 is calculus, but this one is just pure algebra.
Yeah.
Okay, so we're assuming we did that one right. Let's see. I got time for one more, 4.
Okay.
I've done 5, but we can do 5 tomorrow.
Okay.
For 4, I pulled up Wolfram because you can use your calculator on these problems, and it says consider the graph.
Right.
So there's the graph. In other words, Wolfram alpha allows you to put in a parametric equation, just like I did, and it tells you what it is. It's nice. Those are the two equations, and there's the graph. Now the question is use the graph to determine those points at which the curve is not smooth. Oops, find it here. Where's that curve not smooth?
Negative.
Yeah, those 4 vertexes, right?
Yeah.
Okay. So that's what I think. That looks a lot like a cusp.
Yeah.
Although, if you look at it as 4 separate curves, it is certainly smooth there. And it's smooth from this side. So the question, the answer has to be either no points at all or those 4 points, right?
Okay.
One or the other. Well, if I look at the answers, the curve is either smooth everywhere or it's those 4 points. And if you check the points, it's 4, 0, 0, 4. It's not 1. Not this one here. Okay? And it's not just 2 of them. There's no way it could be just 2 of them.
No, it has to be 4.
So it's either D or C.
Which I think it's C, since...
I do too, because if it's not, let's see, I worked out the logic of this, but it has to be none. It has to be C, because if it wasn't C, it would be the curve is smooth everywhere.
Right.
But I suppose that could still be an answer, huh? Yeah, reason my logic, I had it worked out differently. I think the answer is C, but he may ask you to prove it and to tell you what it means to not be smooth. In other words, it's one thing if we're looking at a curve that does this.
Right.
It certainly is not smooth there. And, there's official math definition for that. That is the one case to determine a cusp. You have to prove that the derivative from the left side is not the same as the derivative from the right side. And when you have a cusp or a corner, that's the case.
Right.
That is going to be the case on this also. Ooh, or is it? Hold on a second. Hold on just a second. If I examine each of these points to determine whether I'm looking at a cusp or a curve, the derivative is approaching 0 from the bottom, and it's approaching 0 from the top.
Right.
It's not the same as if I look at a curve like this. The derivative from the left is negative, and the derivative from the right is positive. Wow. See, the reason it's a little tricky is because we're not looking at a function. Notice that thing does not pass the vertical line test.
Right.
Whereas everything else, when you've been checking for cusps and everything, they've always been functions. So I know that mathematically that is a cusp, but is this? which is what we're looking at those two spots. So I could conceivably believe that the two vertical vertices are not smooth, but the two horizontal ones maybe. Let's take a look. Is that an answer? I think it is an answer.
It is an answer.
Yeah, A. 4. Oh no, that would be the two horizontal ones. No, that can't.
So it is C.
I think so, yeah. I think it has to be C. I mean, intuitively it has to be C. I just wondered if the fact that it's not a function, whether that affects things.
Right.
So I don't know, but you'll find out when you get the answer, Kurt.
Okay.
Okay?
Thank you.
I'll talk to you tomorrow.
Yep. See you tomorrow.
All right. Bye-bye.